つけてみたけど、なんかノットサービスって書いてたから、いいやと思って、もう無視して。
Anybody want to ask about any of them? B. Now, B is a little tough to complete the square. Why? Because it's not an even number. So I would have gone with Vx equals negative B 5 divided by 2. Then you take that and you put it in here. Y equals 5 over 2 squared minus 5 times 5 over 2 plus 2, which is 25 over 4 plus 50 over 4 plus 8 over 4. Sorry, minus. 25 minus 50 is negative 25 plus 8 is negative 17 fourths. So that's your y-intercept. So that goes there, and you already had the x right there. Yeah? I should have done that a different color. Sorry. That's B. Anything else from that page? Sweet. Remember, I said I didn't care if you completed the square or you used the other move. So, this is y equals x minus 2 squared minus 2, which of course looks like this. Out 2, down 2. Whoop! This is y equals x plus 4 squared minus 3. So it looks like this, negative 4, negative 3. Whoop! This is y equals x minus 4 squared minus 1. So it looks like this, out 4, down 1. Whoop! 4 is y equals x plus 3 squared plus 3. So it's out here at negative 3 and up 3. Whoop! Please stop me if you need anything there. Once, twice, thrice. Lovely. 3. Okay. So since that's an even number, I, of course, would recommend completing the square because it is less work. So that is y. I like to bring the 15 over here to get it out of the way, but you don't need to. Equals x squared minus 8x plus 16. Plus 16, so y plus 1 equals x minus 4 squared. Bring that back over. Y equals x minus 4 squared minus 1. Yeah? Yeah. 5 and 6. Y equals 2. X minus 1 squared minus 4. So it is over here at 1, down 4. But you got to make it skinnier because of the 2. And this one is y equals 2x plus 2 squared plus 2. So you're over here at negative 2 plus 2, and you got to make it skinny. Everybody okay there? Once, twice, thrice. Cool in the gang. Then you turn the page over and, oh, what has changed? There are negatives now. So what does that mean to all these parabolas except number 9? He waited patiently for his class to answer. Sad face. -4 plus 4, but negative, so skinny and down. Y equals negative x minus 3 squared minus 2 plus 3 minus 2 down, but not skinny because it's normal. 9 is y equals x plus 1 squared minus 4. Out at -1, down 4, and normal, not skinny. And number 10, y equals -2, x minus 1 squared plus 2, plus 1 plus 2, but negative and skinny. Any questions from 7, 8, 9, 10? Okay. Y equals -2x, x minus 2. Did I do it that way? Yes. And then, of course, no. -2 x squared minus 2x. Yes. Now I would complete the square. Half of 2 is 1, squared is plus 1. So I've added 1 to both sides. Equals -2 x minus 1 squared. Then bring that 1 over, minus 1. And 11 is y equals -x minus 1 squared minus 4. 1 minus 4, not skinny. Y equals 2, x plus 4 squared minus 2. -4 minus 2, up and skinny. And y equals, oh, tricky one here. X minus 3 over 2 squared plus 7 over 4. So it's out here and up and normal and not skinny. And y equals negative, oopsie daisy, negative x plus 5 over 2 squared plus 3, negative, plus, and down, and not skinny. Any questions about 11 through 14?
14.
12 and 14. Okay. So, 12, excuse me, I like to get rid of this, right? Because it just messes me up. So y minus 30 equals, now I don't want to do complete the square there because I don't like a 2 at the front, so I take the 2 out. X squared plus 8x. What's half of 8? What's 4 squared? 16. So I've now added 32 to this side. So what do I add to this side? Plus 32. So that's y plus 2 equals 2, x plus 4 squared. Bring that over. Y equals 2, x plus 4 squared minus 2. And 14. Again, I like to get that out of there. Y plus 13 fourths equals negative x plus 5x. Half of that is 5 over 2. 5 over 2 squared is x squared. Yes, Ayaka. Plus 25 over 4. So I took away 25 over 4. Yes? Which is y equals, y minus 12 over 4, which is y minus 3 equals negative x plus 5 over 2 squared. Then you bring the 3 back there. Okay? Okay. Everybody is good? Excellent. We'll have to have a quiz pretty soon, I think. If you would be so kind as to turn the page over to 106, if I am not mistaken. So, we have just reviewed vertex form, yeah? Right? Vertex form being y equals ax minus p squared plus q. P and q are the vertex, right? And A tells us our y value stretch. And I put stretch in quotation marks because when I say stretch, you generally think I mean this, yes? But I also mean the shrink, which would spread it out. Right? Everyone is good with that? Everyone remembers why that works? Because of y equals x squared, how we moved that all around and we could make this work. Everyone was good? Okay. Notice this is in a slightly different form, correct? Right? I still see p and q, but the x is no longer squared, it's here, right? So this will give us different information because this is a different form. This is vertex form, which if you look back in your notes, I said was the first way we were going to learn to deal with parabolas. Now we're on the second way we're going to learn, factored form. Now this gives us different info. Different info from vertex. All right? Everybody cool? So, in here, A is still the stretch, which is still counted from the vertex. But you will notice this does not give me a vertex. Okay? This, even though it has P and Q, this gives me the roots. And what are the roots really? They are the x-intercepts. And where does an x-intercept live? It lives at x, 0. Everybody right? Everybody understands that, remembers that, right? Now, if it's a parabola, it's going to have one of three options here. It will either be x1, 0 and x2, 0, or x0, or there will be none. Right? So, how do we find these? Well, what is the same in all of them? Y is 0 every time, correct? So what number would I put there? 0, which we already know how to do from our factoring lessons. 0 equals A, x minus P, x minus Q. Which means, Mr. Friesen, what can I do for you?
Sorry.
No problem at all.
Could I get a toner?
I don't have any toner for that. Well, I have been told that it is not the same, and I've been told that it fits. Okay. So let's see. Like a magician. Looks the same.
Okay, thank you.
That is the wickedest bubble wrap ever. Who wants in? I know some of you do. Bubble wrap popping is awesome. I could use it. Oh, wait a minute. Oh, I could use it to take a nap. Oh, I can use it to block out the whining cries of my students. This is like the gift that keeps on giving. And I could do all that with it and still pop a few. Nothing up my sleeve. All right, let's do math. Apparently it's recyclable. All right. Yes. So what does this mean? My pen's not working. My pen. Somebody stole my pen. Come on. Really? My kid says that all the time. And then I show him what bullying really is.
Oh my god.
So, this of course means two things. It means x minus p would have to equal 0, which would mean x would have to equal p, the opposite of what you see, or x minus q would have to equal 0, so x would have to equal q, the opposite of what you see. Yes? Now, we all know that will give me two dots that live where? Where do those dots live? On the x-axis. So I would have a P and I would have a Q. Correct? What do we know about the horizontal distance between those two compared to the axis of symmetry? It's what? It's the same. This distance is x on the x value, yes? What is this distance? Also x. So, does that not mean that the vertex is exactly between the roots? Right? So if this distance from here to here is p, and this distance from here to here is q, what does that tell us? If I add those two and divide by 2, I will get this. Does everybody understand that?
Divide by 2?
Of course, because I'm finding the middle between the two, aren't I? Am I not? Everybody good? So, let us now apply all of that knowledge to here. Can I find the roots here?
Yeah.
Damaris. You are finding the x value of the vertex, which is also the equation of the axis of symmetry, which we're about to do right now. It becomes more clear when you see it with real numbers. Okay? So looking at this, of course you can memorize the shortcut, yes? But I do not recommend doing that until when? Until you understand the shortcut. So we're going to do all the work here. To find the zeros, 0 must equal x plus 3, correct? Which means x must equal negative 3. Does everyone agree? So where is x equals negative 3? Where? On the x line, which way? Left 3. 1, 2, 3. Does everyone agree? Great. What's the other one? 0 must equal x minus 1, correct? So what must x equal? 1. Where's that? Right 1. Does everyone agree? Great. How far apart are those?
4.
4. So the vertex has to be directly between the two, doesn't it?
Yeah.
So what is 4 divided by 2? 2. Everybody with me? So we know the vertex has to be 2 on either side of this, yes?
Yeah.
So if I go 2 from negative 3, I'm at negative 1, yes? If I go 2 from positive 1, I'm at negative 1, yes?
Yeah.
So the shortcut is this. What is 3 plus negative 1 divided by 2? Sorry, it's opposite. Right? Negative. What is negative 3 minus, I wrote it down here, minus 1. Because that's opposite, negative p, negative q. What's negative 3 minus minus 1? Negative 2. What is negative 2 divided by 2? Negative 1, which gives us our vertex at negative 1. Is everybody cool? You can see it when you draw it out, but you can also find it with algebra. Everybody okay? All right, let's do this one, and let's again find it properly, and then we'll use that to visually find the vertex, and then we'll do it algebraically. All right? So, what does this mean? X plus 3 would have to equal 0, yes? So x would have to equal what? Negative 3. And then on the red side, x would have to equal 1, yes? So it's the exact same one we just did. Visually, 1, 2, 3, 4, correct? Yeah. What is half of 4? 2. 1, 2. So here is our vertex. It is on here, yes? That's negative 2. Negative 1. No, that was negative 1. I drew it right the first time. Here is where our axis is, yes? Which means the vertex lives somewhere on here, correct? Now, what is different between 1 and 2?
There's a 2.
There's a stretch factor, yes? In this one, there's no stretch, right? So if I go 1 away from my vertex, I need to go up 1, correct? If I go 2 away from my vertex, I need to go up how far? 4. So here's my 2 away from the vertex, yes? Which means I must have had to go down 4, correct? So my vertex is here at negative 1 and down here at negative 4. Because when I went 2 over, I went up 4. So it's a normal parabola. Is everybody good? It's what we've already done. Does everybody understand what has happened here? You must stop me if you don't. Can everybody find the axis? It's halfway between the two, right? Now, that will give me, graphically, I know that since there's no stretch, if I go 2 this way, I have to go up 4, correct? Everyone agrees, right? So obviously, this point has to be 4 down from there, which would make it negative 1, negative 4. Is everybody good? Okay, now, there's another way to do it. Can you figure that out? Do I know this value? It is what? What is this value? It is negative 1, correct? Is it an x or a y value? It is an x value, isn't it? What letter is that? What letter is that? What is my x value? What is negative 1 plus 3? 2. What is negative 1 minus 1? Negative 2. What is negative 2 times positive 2? Negative 4. And that gave me my vertex. Does everybody understand? Now, some of you will say, I like to be able to count on the graph, Mr. Myers. Have I shown you how to find it counting on the graph? Yeah. Some of you will say, I just want to substitute my points because x equals x and y equals y. Have I shown you that? Everybody's good? Great. So let's look at this one. Counting is kind of a pain, isn't it? But algebra never lets us down, does it? Because what is this value? What does x equal here? X equals -1. What letter is that? What letter is that? So this is 2, this is -2, isn't it? What's 2 times 2 times -2? He waited patiently. -8. So this would be -1, -8. This would be -1, -4. Right? Does everybody understand? Can you find it both ways? Let's check. This first one, we're going to find with counting. This one we'll find with algebra. This one, what are my automatically, you should be able to tell me my roots. What are they? X equals what?
4. Positive.
4 and 6, correct? 1, 2, 3, 4, 5, 6. Agreed? Where obviously is the vertex?
5.
The vertex is at x equals 5, yes?
Yeah.
So, is there a stretch factor here?
No.
So if I go over from the vertex, if I go right 1, I should go up 1, yes? But I don't have the vertex. I have one of my points. So I have to reverse it, don't I? So I go left 1 and down 1, because there's no stretch. And what is that point right there? 5, -1. And I draw my parabola. Any questions? Can everybody find it with counting? Yeah? All right. Now, in this one, we're going to find it algebraically. Vertex X equals P, correct? Right? Plus Q over what? 2. What's P? -4. Plus, what's Q? -6. Right? Divided by 2, what's that? Something's going to be weird here. What's weird? It's -5. Now, we already know it's +5, don't we? So did I do something wrong here? Should I be adding or subtracting? Why is it subtraction? What is the answer in a subtraction question? The difference. And I need the difference between these two, don't I? So I can't add it. You've got to build your own formula. So P minus Q is what? What is it? P minus Q would be, is that right?
Yeah.
That's right.
Because it's positive.
P is -4 minus Q would be -4 plus 6, wouldn't it? Is that right?
Oh, are you not doing dividing too?
Well, even if I divide by 2, that's still not right, is it? Because I know my vertex is 5. Build the formula, guys. -P minus Q. That work? That would be 4, -4, right? Minus Q would be plus 6. Does that work? Okay, so minus a minus, isn't that the same as adding? But we already tried that and it didn't work. Or did it? That says positive P, right? It says P. That is P. That is Q. 4 plus 6 is 10 over 2 is 5. You have to be careful with what is subtraction and what is negative and what those terms mean. And it messes kids up all the time. This is negative 2. Where is it on the number line? There's 0. Negative 1, negative 2, correct? But I can also use this to show 7 minus 2 in math, can't I? How do I do this on here? Where do I start? I start out here at 7. How did I get to 7 from 0? I added 7, didn't I? Because this is positive 7. So what should be here that we don't write? Positive. Because really everything starts at 0, yeah? So I went positive 7, and then what did I do? Negative 2, correct? To get to 5. Everybody with me? Now what is really happening here? This is really, I'm going to change colors to a third color, positive 7 plus negative 2. Right? Positive 7 steps and then negative 2 steps. Subtraction doesn't really exist. It's adding negatives. Everybody with me? So when I show you this, x minus 7 and x minus 4, what is that really? That is really x plus what? Negative 7 and x plus negative 4. Everybody with me? This is a shortcut of this. Is everybody cool? Can you guys please shut up? You know what? I'm sick of it. You over behind Burke. One of you move. You got 5 seconds to decide who. 5, 4, 3. Good. Stay there. Is everyone good? Awesome. So now let's go back over here. P plus Q. I leave it. Okay? Now, we know it's going to be 5. Is that 5 an X or a Y? That's an X. So what can I do everywhere I see an X now? Put in 5. So what is 5 minus 4? 1. What is 5 minus 6? Negative 1. What's 1 times negative 1? Negative 1. What's negative 1 times positive, or negative 1/2? Positive 1/2. So I know my vertex is at 5, positive 1/2. So I'm gonna stretch this so it looks bigger, right? 5, and I'm going to stretch on this axis. There's 1, right? So that would be a half, correct? So I'm out at 5, 1/2. And then what does that mean? It opens downwards, and it has to go through 4 and 6. Is everybody cool? All right. I want you to be able to do both. So let's look at this one. What does this mean if we're counting? What are my two x values? Does everybody see how Lucas got that? Because, of course, either x would have to equal 0 or x plus 2 would have to equal 0. Everybody can do that, right? So where are my two roots? One is right there, and the other one, I'm going to stretch way out here so it's easy to see, negative 2. Everyone is good? Okay. Where does the vertex have to be? right between the two of them, yeah? Just by counting. So I know my vertex is here. Is there a stretch? No. Because this is really x plus 0, right? So is there a stretch? No. So when I go over 1, I should go down how far? Down 1. Correct? So that point right there is what? What is its value? -1. -1. Yes? And then we make our parabola, and it opens upwards. Why? Because it's positive at the front. Can everybody do it? Yeah? Okay. Look at this one. It's tricky. Look at it very carefully. We want to do this one algebraically, yes? So what's the first thing I need to find before I can do algebra? I can't find the Vx until I have, well, I could. Should I find the roots or the Vx first? Or does it matter? It doesn't really matter, does it? Except it's a little hard to find the Vx from this point. Why?
Because there's a 2.
The 2 makes it weird. So I would recommend finding the roots first. How do we find these roots? X equals 1/2 and -4. Does everybody see what Lucas did? Everybody? Okay, so where's 1/2? Right or left? Right. There's 1/2. -4 is way out here, correct? Now this is really hard to count, isn't it? Why? Because of this fraction, yeah? Fraction makes it a pain. But we know that this distance is 4, right? And what's this distance? 1/2, correct? So we know that the whole distance is 4.5, right? Half of 4.5 is what? 2.25, 2 1/4, correct? So if I go 2 1/4 from either side, I'm in business, yes? But I said I wanted to do it algebraically, right? I didn't want to count it. So how do I do that algebraically? What do I have to do with these two numbers? If I add them, 1/2 plus -4 and divide by 2. What is 1/2 plus -4? (1/2 plus -4. -3.5, yes? Everyone agrees? Everyone agrees? What is that divided by 2? -1.75. Does everyone agree? Everyone agrees? Okay. We also know that this is 4.5, correct? Half of 4.5 is 2.25, yes? So I'm going to go 1 to -3, yes? 2 to -2, yes? And then another quarter to negative what? -1.75. There it is. If I just add the roots, whatever I see, I'm going to get my x value. Is everybody good with algebra? Now there's no counting, remember. I didn't want to count. So what do I do with this x now? I put it in where?
X.
Everywhere I see an x. So 2 times that we know is negative 3.5 minus 1 is negative 4.5, yes? And negative 1.75 plus 4 we know to be positive 2.25, yes? Then I got to multiply that. Hard to multiply in my head with decimals, easy with fractions. Right? Super easy with fractions. What's this? 4.5 is 9. Sorry. 9 halves, yeah? What's 2 1/4? How many quarters? 9 fourths. 81 over 8, yes? So how do I graph that? How many 8s go into 81? 10 and 1/8, yes? So my vertex must be, sorry, Mr. DeVries, at negative 10.125 or negative 1 3/4 and negative 10 1/8. Can everybody work with both? And a better question is, do you really have to be proficient with both of them? No. As long as you can do one of them, you'll be able to get through the whole course, yes? But a great many of you are very scared of fractions. So knowing the algebra is kind of easy when it's just numbers. But when it's fractions, you might want to count. Who has to make that decision? You do. So what do we know right now that we can all put in one place? What do we know here about P and Q?
The opposite is the roots.
Right. The opposite of P and Q are the roots. And they have another name. We also call that the zeros, right? On our graphing calculators, yeah? How do I know that? Because x minus p must equal 0 and x minus q must equal 0. So x equals p and x equals q. You see a negative q, the answer is positive q. You see a negative p, the answer is positive p. What if I had plus p and plus q? It would be negative p and negative q. Everybody good? Everyone can find the roots, yes? Yeah? Now, how do we find the vertex? There's 2 things there. 2a. The vertex is where? Where's the vertex? 2 ways to find it. We just did them both. Somebody tell me one of them, please. Right. Vertex is halfway between the roots. That's true, always, right? 2 ways to find it. 1, you could count. Counting on the graph. That will work, won't it? If I'm at 5 and 3, halfway between that is 1. 4 on either side, right? The second way to find it is doing P plus Q divided by 2. That will get me the vertex X-axis. Vertex X-axis. Or vertex X. Once I know that, I can go to my third spot and I can sub the vertex X in for what? In the original equation. In for X to get vertex Y. And what's the thing I got to remember always? A positive, what kind of parabola is it? Up. A negative, what kind of parabola is it? Opens down. Is everybody good? Now again, I ask you, was there anything new here? No, but it's starting to pile up, isn't it? Because there's so many different ways to look at a parabola. What makes you decide if you're going to do vertex form or factored form? Which is easier at the time, right? If I gave you this, and I told you to graph it, would you use factored form or vertex form? You'd use vertex? I'd use factored because that's x plus 3 and x plus 4. Right? But if I gave you this, now what? You should complete the square or do that other trick, right? Where we use negative b over 2a. Because this doesn't factor. Is everybody good? It depends on the equation you get, what method you're going to use. Okay? Now, like always, all that stuff's right here for you. We're going to do the first two together, and then I'm going to shut up and let you work. What are we going to do there? Does that one factor? I'll give you a hint. We're doing the section on factoring.
Yeah, this will.
Does that one factor?
Yes.
Yeah. So what is it?
Y equal x plus 5 and y x minus 2.
X plus 5, x minus 2, correct?
Yes.
So now I know P equals what?
Negative 5.
Negative 5. And Q equals what?
Positive 2.
Positive 2. So negative 5 plus 2 over 2 equals my Vx, yeah? What is that? Negative 3 halves, correct?
Yes.
Okay. Now, what can I do with that over here? I can sub it in for x, can't I? So y equals negative 3 halves plus 5. Now 5 is really 10 over 2, correct? And negative 3 halves minus 2, which is 4 over 2, correct? What's negative 3 plus 10? 7 over 2. And what is negative 3 minus 4?
7 over 2.
Negative 7 over 2. What is 7 times negative 7? Negative 49 over 4. So now I know everything, don't I? My roots are what? I'm going to come over here. I'm going to put everything I know before I even go to my graph. What are my roots? Negative 5 and 2. What is my vertex? What's the x value of the vertex? Negative 3 over 2. And what's the y value?
Negative 49 over 4.
Which I would say is negative 12 and 1/4, because that's easier to graph, yes? Now let's graph it. Where's negative 5? On the left. 1, 2, 3, 4, 5. Right there. Agreed? 1, 2. Agreed? That distance is 7, correct? Half of 7 is 3.5, right? 1, 2, 3.5. That is negative 1.5, isn't it? Which is exactly what we had. Negative 1.5. And down how far? All the way down. Now, that's going to go off the graph, right, if I keep this scale? So how do you show me that you know what you're doing?
You can write negative.
You write it. Negative 3 halves, negative 12.25. And then you draw it for me. Is everybody cool? Everybody cool? Okay. Now, since this is factoring section, we're going to factor this, even though we don't have to, correct? Let's factor the second one. How would I factor that? I need to multiply to what? Right. I need to multiply to negative 6 and add to negative 1. So it's minus 3 plus 2, right? So it's x minus 3 over 2 and x plus 2 over 2, right? Then I tidy it up. 2x minus 3 and x plus 1. Now I'm in factored form, yeah? What are my roots? 3 halves and negative 1. Is everybody good to there? Yeah? Okay. What is my vertex X-axis? It's a little tricky. Should I look on yellow line or blue line to do this? Look up at the top, because if we did it once in math, it's the way we always do it. Yellow line or blue line? Remember, x minus p, x minus q. That's what the regular form looks like, correct? There it is right there. xp, xq. X is by itself, yes? Which line, yellow or blue, has x by itself? Yellow. So which one should I use to do my Vx? Yellow. What is P? Negative 3 halves plus positive 2 halves is negative 1 half, and all that needs to be divided by 2, doesn't it?
Yeah.
Which is what?
Negative 1 over 4.
1/4. Is that an x or a y value? X value. So where does it go? Where can I put it? Everywhere I see an x, yes? So 2 times 1/4 is negative 2/4, right? So that's negative 2/4 minus 3, which is negative 12/4, correct? Right? And what goes here? Negative 1/4 plus 4/4 is what? He waited for his class to tell him what negative 1 plus 4 was. 3/4, which is negative 42/16, which is what? Please hurry, guys. I have to pee.
2 out to 10 over 16.
2 3/4, isn't it? Or 5/8, right? Now graph it. Our roots are at 3 halves, right there, because there's 1, there's 2, 3 halves, and negative 1. Right there, yes? Halfway between the two is 1/4. That makes sense. And then way down here at negative 2 and 5/8. And then I would label that as negative 1/4 and negative 2 and 5/8. And I would draw my parabola. You guys need to try these on your own. Because I got to pee. Try those two. Are they going to factor?
Yes.
Yeah, because we're in the factoring section, right? So factor them. And
Oh, yeah.
remember everything you need. There's everything. Your homework is up to and including page 109. And then you will notice page 110. See how it's a whole review thing? Standard vertex factored. We're going to fill that in tomorrow. Then I'm going to give you a quiz on that page. Page 110. I'm going to give you a couple of questions of parabolas to graph. They will be in one of those three forms. You are going to graph them. Everybody understand? Yeah? Quiz Tuesday on P110, which we're going to fill in tomorrow. We'll have the quiz at the end of tomorrow after we discuss it all. Everybody good? Going once? Everyone is good? All right, I'm going to pee. Is that all right with everyone? Well, you don't really have a choice, so...